Hello everyone and welcome to our channel Schrödinger's cat, and this is Devabroto. Today we will discuss the important topic, the special theory of relativity under the chapter the classical mechanics, and it is very essential and important for the IIT JAM, JEST, NET, GATE and TIFR also. So let's get started. So basically we have the introduction part about our topic, the special theory of relativity. So here you just see that there are 7 topics mainly. So one is Galilean transformation, second one Lorentz transformation, third one is the consequences of Lorentz transformation, relativistic velocity addition theory, relativistic mass, momentum, second law of motion, energy, kinetic energy and relation between them, Doppler effect in light, questions and solution of NET, GATE, JAM, JEST and TIFR. So basically in classical mechanics, in JAM, IIT JAM, here the number of question here 8 to 9. JEST, the coming number of question in this topic classical mechanics 9, and 1 or 2 question from this STR topic, and in NET here is 7 to 8 questions, and after that the GATE exam we have question 5 to 6. So we just go ahead our discussion. First one is the transformation. So basically we have two frame, that origin x, this is x dashed, y dashed, and another one is z dashed. This is basically o dashed. So first the Galilean transformation, first we just summarize the topic and after that discuss question. So the transformation is basically the Galilean transformation x dashed x minus vt, reverse transformation x equal to x dashed plus vt. So y dashed is equal to y unchanged, z dashed equal to z, t dashed equal to t, and here y equal to y dashed, inverse transformation z equal to z dashed, t equal to t dashed. And second one is Lorentz transformation. Here is basically x dashed gamma into x minus vt, y dashed equal to y, z dashed equal to z, t dashed equal to gamma into t minus vx by c square, where gamma is equal to 1 by root over 1 minus v square by c square, and beta equal to formally V by C, and their inverse transformation would like to be the x equal to gamma x dash plus Vt, y equal to y dash, z equal to z dash, and the t equal to gamma e dash plus p dash plus vx dash by c square. And one important thing, that x square plus y square plus z square minus c square t square is basically Lorentz invariant quantity. Our next parameter, consequences of Lorentz transformation. So basically, first one is length contraction. L equal to L naught root over 1 minus v square by c square, where L equal to, that is L equal to L naught by gamma, and it should be L less than L naught, where L the length of, assume the rod as measured by an observer relative to which rod is in motion, and L naught be the proper length. Next one be the time dilation. This is basically del t is equal to del t naught by root over 1 minus v square by c square, basically gamma del t naught, and here del t greater than del t naught, and del t time interval measured from S frame, and as usual we get a area a naught by gamma, volume v naught by gamma, and rho naught by gamma. So after one, that the relativistic velocity addition theory in S frame x, y, z, t, s dash, x dash, y dash, z dash, t dash, and the ux be the ux dash plus v by 1 plus v by c square ux dash, uy dash by gamma into 1 plus v ux dash by c square. Next one uz dash divide by gamma into 1 plus v ux dash by c square, and the reverse should be in the form of just plus change to minus, and here should be dashed. This should be minus here, this should be minus here, this should be dashed, this should be minus here, this should be dashed. Basically this represent the inverse transform. So after one we have another that the relativistic mass is basically the m equal to m naught by root over 1 minus v square by c square, is basically m equal to gamma m naught, where m naught is the rest mass and m be the observed mass. Relativistic momentum basically p equal to mv, so m naught v by root over 1 minus v square by c square is equal to gamma m naught v. Another one is the relativistic force. Basically we know F equal to ddt of mv, m naught v root over 1 minus v square by c square is equal to ddt of gamma m naught v. Another one is basically the relativistic energy E m naught c square by 1 minus v square by c square gamma m naught c square. The another one, relativistic kinetic energy K equal to mc square minus m naught c square is equal to gamma m naught c square minus m naught c square, is basically m naught c square common gamma minus 1 and total energy E equal to K kinetic energy plus m naught c square, and this is basically T plus m naught c square. So another one, that the relationship between total energy and momentum, that the E square equal to p square c square plus m naught square c to the power 4. We just recall the formula and after that go through the problems. The another topic, that the Doppler effect in the light. So basically the Doppler effect here is a source and this is the observer, is in perpendicular direction. So our main formula for Doppler effect in light, that apparent frequency nu be the nu naught 1 minus v square by c square by 1 minus v by c cos theta, and for the perpendicular direction, this special case, it would become nu perpendicular is equal to 1 by t is equal to root over 1 minus v square by c square divided by t naught, where nu less than nu naught, and nu is a observed frequency and nu naught the source frequency, observed frequency nu, source frequency nu naught. So when observer and source moving apart, the another condition, observer and source moving apart from observer and source moving apart, this would become nu parallel is basically nu naught root over 1 minus v by c. This formula is very important divide by denominator 1 plus v by c. And the another one, both observer and the source moving together, source and observer. So nu approaching is equal to nu naught, just reverse here, 1 plus v by c by 1 minus v by c. Our next topic, that the 4 vector and relativistic invariance. So here first one, for position x we have is in the form of dx dy dz ic dt. For velocity v, ds dt u is basically gamma ux uy uz ic, and this d2 to d10 u vector ic. For momentum p, for vector momentum iec. The another one is for force, gamma f id I dmc dt, f I dmc dt. And our another one topic, that the 4-dimensional space time continuum. This is S12 square is equal to gamma 12 square minus c square into t2 minus t1 whole square. For space like interval, space like, this condition hold gamma 1 2 by c is greater than equal to t2 minus t1. For time like, that gamma 1 2 by c less than t2 minus t1. And for light like, it would become gamma 1 2 by c, gamma 1 2 means 1 to 2, gamma 1 2 by c is basically equal to t2 minus t1. Go ahead our another topic, that relativity of geometrical angle. Suppose one rod is in the x direction and it make an angle in theta, then we get for tan theta is equal to tan theta naught by root over of 1 minus v square by c square is basically gamma tan theta naught, where the condition gamma is greater than gamma naught. Our main aim to do many problems from CSI NET and GATE, and we also have some Lorentz transformation for force, momentum and energy, like that. For force, fx dashed fx minus v by c square f dot vp by 1 minus v ux by c square, basically the Lorentz transformation for force. Another one is for momentum, px dashed px minus v by c square root over 1 minus v square by c square for momentum p. And another one for energy, E dash equal to E minus px by px into v by root over 1 minus v square by c square. You just to put here f equal to mv, you just put this relation, relativistic velocity addition formula, and you will got the result, this for each energy. So now we just go at the problems. We should go ahead to problems. That our first one. First one is basically a relativistic particles of mass m and charge E is moving in a uniform electric field of strength epsilon starting from rest at t equal to 0. How much time will it take to reach the speed c by 2? So given here, this is a question of net CSIR net December 2018. So basically here given the solution dp dt is equal to charge into epsilon strength. We get here p equal to E epsilon plus constant. Boundary condition at t equal to 0, p equal to 0. We should get the constant value 0. We have know the formula m v by root over 1 minus v square by c square is equal to E epsilon t. So now our t would become m by E epsilon v by root over 1 minus v square by c square. Here we put value given c by 2 velocity. So put v equal to c by 2, we get the result that m equal to, putting v equal to c by 2, we get t equal to m by E epsilon c by 2 v equal to c by 2 1 minus 1 by 4. This would become m c 1 by 2, so root 3 E epsilon. So our answer is t equal to mc by root 3 E epsilon. This is the answer. Next, CSIR net June 2018. We have question: the energy of a free relativistic particle E equal to root over, this root over is whole, mod p vector square c square plus m square c to the power 4, where m is the rest mass, p is the momentum and c be the speed of the light in vacuum. The ratio of group velocity and phase velocity of a quantum mechanical wave packet describing particle would become dash. So you have to find the ratio of group and phase velocity. So we have the relation that E square equal to p square c square plus m square c to the power 4, and we know the relation that the group velocity d dp and the phase velocity vp e by p. So now we just derivative here 2e or d dp is equal to 2pc square, or e by p d dp is equal to c square, or Vv by Vp is equal to c square by Vp square, or Vg by Vp c cube e square by e square. Just put the value. This ddp is Vg, so Vg by Vp equal to c square by Vp square, and our final result would become that p vector square c cube by e square. Another one, question number 3, JEST 2018. A person of Earth observes two rockets A and B directly approaching each other with speed 0.8 c and 0.6 c respectively, at a time when the distance between the rocket is observed to be 4.2 into 10 to the power 8 meter. The clock of the rockets and the Earth are synchronized to t equal to 0 second. The time of collision in second of the two rockets as measured in rocket A frame is x by 10. What is the value of x? So given that the time of collision in second of the two rockets as measured in the rocket A, x by 10. So the time of rocket A measured is x by 10. We just find the value of x. So basically here is given that 0.8 c, just write here v equal to 0.8 c, and ux dash, we here use the relativistic velocity addition theory, that would become ux dash equal to ux dash plus v by 1 plus ux dash v by c square. You basically put the value, we get 1.4 by 1.48 c. After one, we just put here L equal to L naught root over 1 minus v square by c square, the length contraction formula, that L naught 4.2 into 10 to the power 8 given root over 1 minus v square by c square, put in the value, and we get v is already given, so 0.8 c 0.64, and it would become 4.8 into 10 to the power 8 1 minus, so 0.36. After on the time t, we know s equal to vt, so t would become L by ux, that 4.2 into 10 to the power 8 into 0.36 divided by 0.94 into speed of light 3 into 10 to the power 8, and it would become the numerical value you just calculate in your calculator 0.53, and by the question is given this is equal to x by 10, so we just calculate x equal to 5.3. This is our answer. So our next question, question number 4, TIFR GS 2018, that from an observational post E on the Earth, two ballistic missiles, each of rest length L, from nose tip to tail end, That basically means first to last, and are observed to fly past each other with the same uniform relativistic speed c by 2 in opposite direction. What is the time taken for the tail end of one of the missiles cross the tail end to the other missile as measured from the post E? So basically here this is one, and that is one rocket V. So here we should apply that length contraction formula L dash equal to L root over 1 minus V square by C square. So L root over 1 minus C by 2 by C, V equal to C by 2 whole square, it would become root 3 by 2 into L. So total distance cover is basically D 2L. So now D dashed 2L dashed is basically 2 cancel root 3L. So relativistic velocity of left with respect to right missile, velocity of the left missile is equal, velocity with respect to left missile is equal to right missile, and we apply here the relativistic velocity addition formula, that the ux dash is equal to vx ux minus v by 1 minus vux by c square. So c by 2 minus c by 2, here we choose negative sign because one is positive direction to another is negative, and 1 minus c by 2, 1 is c by 2 by c square, and that 4c by 5. So our next t equal to, we know s equal to vt, so d by ux dash is basically root 3l by, we get the result 4c by 5, and after calculation we get 5 root 3l by 4c. This is from TIFR question, and we should solve. Our answer T would become 5 root 3l by 4c. Next, go ahead. The another question, question number 5 from GATE 2019. That the question, two event, one on the earth and the another one is the sun, occur simultaneously in the earth's frame. The time difference between the two events as seen by an observer in a spaceship moving with the velocity 0.5 c in the earth's frame along the line joining the earth to the sun is del t, where c is the speed of light. Given that light travel for the sun to earth is 8.3 minutes in the earth's frame, the value of del t, mod del t is positive in minute, round up to 2 decimal place, take the earth's frame to be inertial and neglect the relative motion between the earth and the sun. This is basically GATE NAT type question, and here just the condition, so two time is same and there are no time separation, so we just write here t2 dash minus t1 dash is equal to 0 first, and the separation of two massive objects, that 8.3 into 3 into 10 to the power 8 speed of light into 60, and after v is equal to 0.5 c. This is given in the question. So we now put the formula time dilation in time invariance under Lorentz transformation, that del t t2 minus t1, that t2 dash plus vx2 dash by c square divided by 1 minus v square by c square 1, and another one is t1 dash plus vx1 dash by c square is divided by root over 1 minus v square by c square. So after calculation we just calculate that t2 dash minus t1 dash by, as it is, 1 minus v square by c square, common here v by c square. Now x2 dash minus x1 dash divided by root over 1 minus v square by c square. So we just put the value and after one get the result 4.77 minute. You just do in the home by using your calculator. So our answer would become 4.77. Next, question number 6 from IIT JAM 2019. The amount of work done to increase the speed of electron c by 3 to c by 3, this would become 2c by 3. C is 3 into 10 to the power 8 and rest mass of electron is 0.511 mega electron volt. So change of kinetic energy is basically work done. Change of kinetic energy means m naught c square by root over 1 minus v square by c square minus m naught c square, another one m naught c square by root over 1 minus v1 square by c square minus m naught c square. So we just calculate m naught c square by root over 1 minus, this is basically 2 v2 square by c square minus m naught c square by root over 1 minus v1 square by c square minus this will cancel, plus this would be plus and cancel, and we put the value. v1 is given c by 3, v2 is given 2c by 3, and m naught c square rest mass 0.511 mega electron volt, and we get the result work done 143.58 kilo electron volt. This would be our answer. Our next question, question number 7 from JEST 2016, that light takes approximately 8 minutes to travel from the sun to earth. Suppose in the frame of the sun an event occur at t equal to 0, the sun and another event occur at earth at t equal to 1 minute. The velocity of the inertial frame in which both these events are simultaneously occur. 4 options are given, which should be the correct. So here the same question we just do after the gate problem, that here given the space difference c into 8 into 60, 8 minutes, minute to second convert and c multiply, and another one time difference is 60. So condition that t2 minus t1 should be 0. Basically t2 dash, here we apply the relativistic velocity, here we apply the time invariance after the Lorentz transformation in S to S dash frame it would become root over 1 minus v square by c square minus t1 dashed plus v x1 dashed by c square by root over 1 minus v square by c square is equal to 0, and after that or t2 dashed minus t1 dashed plus v by c square is common here. V by c square is common here, and x2 dashed minus x1 dashed is equal to 0. So we just put the value 60 is value v plus c square same as, and its value 8 into 60 is equal to 0, and afterward we just get the value minus c by 8. So minus sign here, this minus sign indicate that the frame is moving with the velocity c by 8 vector pointing from earth to sun, earth to sun, earth to sun, not sun to earth. So c by 8, this would be our answer. So go ahead, our next question, question number 8. From net December 2015, a distant source emitting radiation of frequency omega moves with a velocity 4c by 5 in a certain direction with respect to a receiver. The upper cutoff frequency of the receiver is 3 omega by 2. Let theta be the angle as shown in the figure. I should draw the figure in here. For the receiver to detect the radiation, theta, what is the value of the theta? So basically here, that this is our source, this is our receiver, and here the direction, this value 4c by 5, and this angle this is a theta. So here we apply here relativistic Doppler effect frequency. We just write in your theory section, you just got to know. Here we just write omega in terms of nu, root over 1 minus v square by c square is divided by 1 minus v by c cos theta, and omega dash 3 omega by 2 is given equal to omega root over 1 minus 4 by 5 whole square by 1 minus v 4c by 5 to c cancel, 4 by 5 cos theta, and we just solve, and after that or 1 minus 4 by 5 cos theta would become 2 by 5, and after cos theta would become 2 by 5, so 3 by 4, or theta would become cos inverse 3 by 4. So our value, the theta would become cos inverse 3 by 4. This is our answer. So basically these are the questions of previous year NET, JEST, GATE, JAM and TIFR also. Just go ahead, the another. For the homework, the first one is given. My one advice is that you just pause the video and take a screenshot immediately to get the question, and this is your homework for your home. You just try to solve and mail me in the given ID. First question is that in an observer's rest frame, a particle is moving towards the observer with an energy E and momentum P. If C denote the velocity of light in vacuum, the energy of the particle in another frame moving in the same direction as particle with a constant velocity v is dashed. This is basically JEST 2013, and another one question number 2 from JEST and another one question number 3. You just pause this video and take a screenshots here. So our next task, question number 4, 5, 6, 7, 8. The relativistic form of a Newton's second law of motion is dashed. Get 2013. I just write in your theory section earlier, just going through the problem section. Here the formula, you just calculate F equal to ma and put the relativistic velocity addition formula, and you just pause this video and take a screenshot of these questions. So our next task, that for question numbers 9, 10, the muon has a mass 105 mega electron volt per c square and mean lifetime 2.2 microsecond in its rest frame. The mean distance traversed by muon of energy 315 mega electron volt before decaying is approximately dashed. This is from NET 2012. And the another one, the recently discovered Higgs boson at the Large Hadron Collider experiment has a decay mode into a phonon and a jet boson. The rest mass of the Higgs boson and jet boson are 125 and 290 giga electron volt per c square respectively, and the decaying Higgs particle is at rest, so the energy of the photon will approximately be. So pause this video and take a screenshot. So these 10 questions from your homework you just do in your home and mail me in this ID catschrodinger1935@gmail.com. Thank you. Stay happy. Goodbye. So our next class will become in quantum mechanics. Thank you.